So in question 14, we've been given a curve C defined for the range of t is greater than or equal to 0 by the parametric equations x equals t squared plus t and y equals 4t squared minus t cubed. Now, the graph for C is shown in the diagram in front, and in part A, we've been asked to find the gradient of this curve at the point where it intersects the positive x-axis. So we know that the point of intersection on the x-axis is when y is equal to 0. So let's go ahead and find the value of t at y is equal to 0. So at y is equal to 0, essentially we know that 0 would be equal to 4t squared minus t cubed. Now, if you go ahead and plug this into your calculator, we will find that t is either equal to 4 or 0. Now, I'm going to go ahead and utilize a non-zero value of t here. I'm going to reject this value here because later on we will find that the derivative becomes 0 if we were to use this as 0, and from the graph you know that that's not the case. So I'm going to go ahead and use t is equal to 4 and move on with the question. So as I move on, now I want to find both the parametric equations differentiated with respect to t in order to help me find the derivative or the gradient of this curve. Now, for the x parametric equation, I know that dx by dt would simply be equal to 2t plus 1. And then I know that for the y parametric equation, dy by dt would be equal to 4t, sorry, not 4t, it would be 8t minus 3t squared. Now, if I was to go ahead and calculate the values for each of these derivatives, well, dx upon dt at t is equal to 4 would be equal to 9, and dy by dt at t is equal to 4 would be equal to 8 times 4 minus 3 times 16. So that is going to be minus 16. Now that I have my values for dx upon dt and dy by dt, I'm just going to go ahead and use my chain rule in order to find out what my gradient or dy by dx would be. So I know that dy by dx would be equal to dy by dt divided by dx by dt. And so in order to find my dy by dx at t equals 4, I'm just going to go ahead and substitute my values for dx upon dt and dy by dt at t equals 4. So I know that dy upon dt at t is equal to 4 is minus 16. So that'll be minus 16 divided by 9, hence showing that the gradient is minus 16 by 9. So for the first part of 14b, we've been told that the area enclosed by C and the x-axis is given by the equation A is equal to the integral of y dx between 0 and b. So if you just scroll up to the graph, we can see that essentially means between this point here and this point here. Well, we know that this point is 0, and this point is just going to be the point at which y is equal to 0. And we know when y is equal to 0, t is equal to 4. And we also know the equation for x, which is just t squared plus t. And we know that when y is equal to 0, t is equal to 4. So x would just be equal to 4 squared plus 4, which is 20. So thus b would be equal to 20. So for the second part of 14b, we've been asked to use the substitution of y is equal to 4t squared minus t cubed to show that the area is the integral between 4 and 0 of 4t squared plus 7t cubed minus 2t to the power 4 dt. Well, from the previous part or the previous question, we know that a is indeed equal to, or a is equal to the integral of 20 and 0 of y dx, and we can go ahead and substitute our values for y in and our values for dx. So from part A, we know that y is just going to be 4t squared minus t cubed, and dx is just going to be 2x plus 1, and then of course, this, sorry, not 2x plus 1, 2t plus 1. A value for x is going to be 2t plus 1, and then we just have a dt term at the end there. Now, we don't know our limits just yet. Well, actually, we do. We know when x is equal to 20, t is just equal to 4. So our limits are just going to be 4 and 0. And all we have to do now is expand this a little bit. So we get a is equal to the integral of 4 and 0 of 4t squared minus 2t, which is just 8t cubed, minus t cubed times 2t, which is minus 2t to the power 4, and then 4t squared times 1, which is just 4t squared, and then minus t cubed plus 1, which is going to be minus t cubed dt. We can go ahead and further simplify this to make it into 4 and 0 of 70 cubed minus 2t to the power 4 plus 4t squared dt, hence showing what is needed from the question. So for the final part of 14b, we've been asked to find the value of a, and I've got the equation for a written out here, and you can just go ahead and plug this into your calculator, since this question is only 1 mark, and nowhere does it say that we'll be penalized for using our calculator. So you can go ahead and put this integral into your calculator to yield the value of 1856 by 15. Now you can go ahead and integrate it the manual way, I suppose, but I don't think it's really worth it because of the 1 mark. But yeah, so that is it for question 14b.